block or register to the network. The response to such request would be looking like this. So pretty much a similar format. The first line is different because it has the response code, then headers and body. The body, it's where it describes the type of the session. Here it's media audio, so it's a VoIP call, but could be another M line for video and so on. So practically the goal of Kamailio is to sit somewhere in the network and route such packages between phones, between gateways, between media server, because if someone is not answering, there could be a voicemail service that Kamailio will keep the ringing state to a phone for like, I don't know, 20 seconds, and then will stop that branch of the call and redirect the call to a voice box service so the people can leave an audio message that could be played later. And different other kind of situation with application server integration with and actually it's an evolution right now because Lua, the embedded interpreter, was added like 8-9 years ago. And recently, and I'm gonna have the details present in the next slides. Because we are routing packets and we are targeting to be quite flexible because, again, SIP could be used in so many scenarios, but then it's a text protocol and you need sometimes to remove add headers. We started back in 2001 with this project, and our configuration file, actually, it's a scripting language itself. So it has, at the beginning, some part with what we call global parameters, as you see there, like debug to listen, where Kamailio should start listening for SIP traffic. Then we have a modular architecture, so you need to load extension as we call them module. You set parameters for the module, and that would be the passive part of the config file because it's interpreted only at startup, and then that's it. And we have what we call routing blocks, and that's the active part of a configuration file. And that's executed for each SIP message. So it's kind of a rudimentary scripting languages. We have if condition, we have assignments, some string operations, some arithmetic operations, some modularity, as you could define route blocks that could be executed from another route block. We call action what's inside this function and expression inside the routing blocks. Some control statements like exit, return, and so on. So while we are right now here, again, this programming language was designed at its core. It was extended, of course, along this year, but the concept was started in 2001. And actually, we as developers, we try to focus on putting their features for voice over IP, real-time communication, not really becoming yet another scripting language programmers out there. Because, again, one of the main targets for the application was performance, and many of us there being computer science engineers, and worth to mention, the project was started in a research institute, so it was not really a pressure for production. People had time to optimize there. And for this, some of the characteristics, we do a pre-compilation at startup, so we optimize if there are like regular expression in the config file. We compile them to binary formats. We do linear execution, so one by one, of course, following the branches for if, jumping when executing routing blocks. But then also we have quite a lot of limitation because we practically have support only for integer and string values. Extending this language requires C coding and some other tools sometimes like Yak and Bison for those familiar. And our startup optimization, this pre-compilation was not really designed for something that people demand quite often in real-time communication, reloading the config, because they're afraid of not impacting the active call at the moment. With signaling only, as we don't process media, this is not that visible, but still, people demand it, and there are some cases where you don't really want to restart. So at some point, I sort of, instead of from time to time someone comes and says, I want to do now this kind of string parsing, is there a function for it or it's an expression for it? And we added quite a lot, but then again, keep adding. When one of your community users is asking, you kind of feel, again, working on something that is not the main purpose of this project. So it's when I looked for a scripting language. Initially was ability to execute inside our configuration file, inside our routing blocks, triggering the execution of a script that it's loaded at startup. And I added this app Lua module, so executing application scripts in Lua. And from the beginning, I targeted to be able to reload the script if you want, but actually the support was added by Victor reloading, if I remember, back in, I don't know, a few years or several years ago. Probably everyone knows here about Lua and embedding it. It's very simple, and we sort of have our modules, and then exporting to Lua would require to make a wrapper. There are some tools out there that you can get the skeletons and so on, but it feels a bit heavy. And the issue was that having the dependency of Lua in each module was not really a solution, as people want to install as less as possible dependencies, and some people like other scripting languages. As I said, someone else added Python, someone else added Perl. We didn't want to have each module depending on all of them. So one of the limitations of this module was like someone adds a Kamailio module, and then if he wants to export to our Lua module, because we exported to Lua this SR module, SIB routing, we require to add to app Lua another wrapper. So that was a bit of an overhead, and also the app Lua had to bound to our module. We have some inter-module interface and things like that, but still was not like automatically. However, this kind of scripting was quite useful. I use it in many of my deployments. At the beginning, for example, we didn't have like an HTTP client, and I used Lua with the HTTP module to do queries and fetch like JSON documents, and then handle it inside the Kamailio configuration file. So practically, like last year in spring, I did an analyzing, and we are doing quite well with handling document information. We have parser in the config file for JSON, XML, serialization, comma separated list, and so on. For the transport, meanwhile, we had the HTTP client, but also JSON RPC client, SIP, You could interconnect with other API services even by SIP, or build your own protocol as we give a basic connector for it. But the control was, again, the one that was actually requiring changes in many places, the interpreter. And we had this embedded execution inside the config file, or better said, inline execution in the config file. But it was a bit like, okay, I have my config file here, and I have a Lua script there, and from my config file, I execute parts of that Lua script. And again, those limitations mainly on reload and language extension, double or other kind of arithmetic operations that people want to use now for random decisions, because, for example, what could happen in a real-time communication if it's a blackout of the network and you are a big customer, like a big customer user base. If you have like 10 million phones connecting to your service and the network is down, then in 10 minutes you get 10 million registration at a moment, and you need to randomize that because you don't really want like tsunamis coming every 20 minutes when the phones re-register. So you have to reject in the first phase, telling to the phone, re-register in 2 minutes, and you need sometimes a bit more, you know, this kind of math operations. So the solution was, after discussing like making the active part possible to be executed in different scripting languages, and actually we are now just to release Kamailio 5.0 as we labeled the version number. Probably by end of February will be out there. And all those routing blocks that I had an example before, and I'll have some comparison next, could be now in the full in Lua, and right now JavaScript and Python. Perl hasn't been extended because it needs to just hook to a interface that we call it Kamailio embedded interface, which practically it's a kind of abstract structure. Each module exports to this list of Kemi structures, and then each language, embedded language module, it's fetching from there and exporting to Lua, Python, and so on. So again, the core parameters of our application loading modules, Kamailio modules, not Lua modules, just not to be any confusion. And setting the parameters for Kamailio modules, it still has to be a native one. But then you can specify the routing scripting language for active part. So by putting this CFG engine, if you don't set it, it will be the native one, but you can set it to Lua, to Python, or JavaScript with duct tape. It's an interpreter that it's easy to embed, and actually it's practically like Lua. If you really need to do something and you are familiar with Lua and you want to do it for JavaScript, this is following the same concept with states and so on, and is just changing some structure. Sometimes it was like taking the Lua function and changing from Lua state structure to JS state or something, duct state. As I said before, we had this module exported to Lua SR, where we exported our C function to Lua script. Not to break that, I exported another one, KSR, so Kamailio C routing, and there is no need to touch our Lua module to export from your Kamailio module. You just have to put it in your Kamailio module. I want to export to Kemi interface these functions, and that's it. So no more C coding in app Lua. And again, you put everything as a script. You don't have like a route block in Kamailio executing a function from a Lua script or executing a full Lua script. So here it's a comparison, actually, what would be a native. This is native, a request route, and this is Lua. In Lua, there are some predefined names for functions that are executed. For example, request route is executed when we get a SIP request. The equivalent of that would be defining a function KSR request route, and then you can start executing other function that you export inside or you implement inside the Lua script. So practically, here we call the route recinit. That will be like a function. And there, it's up to you to choose the name, because KSR underscore route recinit, it was just my option here to make it a bit of equivalent. But instead of that, it's up to you to choose a name for the function that we execute in the script. It's no longer mandatory to have like KSR request route. So I use some similar names for the subroutes, similar names for the Lua functions. And then you see here like execution of a function exported by Kamailio KSR module, like getting a variable, checking if a transaction exists, KSR, TM, it's our module, transaction management, and tcheck trans tells if it's a retransmission of that request, and then you can decide what to do. Again, we have subroutes in Kamailio, like route not detect. This is part of our default config file. It's why I use it for the example, so people can make a one-to-one relation. Here I define function KSR route not detect. Again, my choice of name this time. You could change it to something else completely. And inside it, you use this function exported by Kamailio KSR module. Of course, this is one-to-one relation, but the thing it's Lua benefit would be to put something in between, which is native in Lua, and it's an extension that in Kamailio doesn't exist. It's where most of the people will add a new feature to their service besides this, reloading. This, in the previous slide, was like a basic service, so I put here a link to a more complete configuration file that has, like, detecting attacks, authentication, authorization, accounting, location services, net traversal. So you can go to this link and you will see, or actually probably I can, it's maybe at the end I can show it if I have enough time. So this would be the description, and now actually I want to go a bit into developer, because FOSDEM is about developers, and actually I have also some question, maybe some Lua guys, but also our guys from Kamailio, because there are some of them that really work with this module, Hugh and Victor here. They are also very good friends of Lua. So again, summarizing, we have to be fast, very fast, because there are deployments out there using it, and they have millions of active users, and some of them are not targeting residential, but they are like carriers and routing like several billions of minutes per month. So that's a critical feature. We call it like transaction or call setups per second, because again, we don't deal with media. Our job is to connect people. After that, if you want to use audio video, we have a helper application in case of net traversal, but typically SIP is supposed to be like peer-to-peer direct media streams. And also, I want to be dynamic. Again, we have our modules. It's not easy to know which module a user wants to use in its config file. And then exporting what that module does to Lua has to be done without really changing Lua, our Lua module, up Lua. And also, I was looking to preserve as much as possible the experience from our native scripting language, and one of the features I found it a bit tricky was this stop of the execution of the routing script. What's in Kamailio config file is the exit. because the exit from Lua, it's actually stopping the interpreter. The interpreter is Kamailio now because it's already embedded there. Killing Kamailio probably nobody wants to have, right? For each call, like we have, relay exit. That will mean relay and kill Kamailio, right? So the solution for this one, as it was the simplest, or one of the simplest that I could find, and maybe someone has other ideas if they are more familiar with Lua, was using the error. So error, practically, it's stopping the config file, it's throwing like an exception, more or less. And I do it with a special string. So when you call error, you have to give a message for the error. And I choose a string like this, tilde, tilde, ksr, exit. And I catch it inside Kamailio wrapper to the Lua interpreter. And by that, I emulate the exit. And seems to be fine. I was looking at eventually optimize it a bit more instead of a string to try to use some integer values there, but it was fast enough for what I needed. So this is the implementation of the exit inside our module KSR. You will have to use this function. Don't use the Lua exit. Use KSR X from extensions and exit. So it's not exported by another Kamailio module. It's exported by app Lua. This would be the implementation. And here is how we handle. This is the main function that executes Lua script and gets the response. And at some point, if it was an error, we actually check to see if it's that string. And if it's that string, we don't actually say it's an error. We know that actually the user wanted to do an exit of the execution. Now, going to the next one that I had the dynamic and fast. The initial approach was like how I export some modules to our KSR based on what other Kamailio modules are loaded. So practically on the KSR, then the module naming Kamailio TMSL, and then functions. And this could be dynamic. And the first solution I found out there was changing the index of the hash table, because in Lua, pretty much everything is a hash table, including a module. And you have the option to change the index of that module. So instead of just looking for a function inside the Lua interpreter, we'll execute a C function, which will look up the Kamailio extension and will execute that. And actually, it was working quite fine, but at some point, I was start wondering if I'm not too intrusive inside the Lua. And changing that indexes of the function felt like maybe this, the guys that really develop this module find new solution. Computers evolve. There are different optimization that may do there. And then it's more like just messing around more with it. It was rather simple. My test was really fast. This is practically the index function. So instead of using the native Lua index, I had to implement a small wrapper inside Kamailio, which is searching in the list of the existing loaded modules and finding the function that was supposed to run. Again, summary of this approach, and my concern about this was, just messing up with the index capability might not be the right approach. So then I went for the second. Actually, both of them are still present. We could change it very quickly. It's probably 2 or 3 lines of code to change from one to another, because the embedded interface stays the same. I went for kind of making one-to-one relation by estimating the maximum number of functions to be exported by Kamailio modules. And I looked and I said, okay, people might combine like 20, 50 modules. TM is the largest, 100 exported function. Okay, we don't export all of them to Lua. And actually, it makes no sense to export all Kamailio functions to Lua, like substring, or other string parsing functions that are also in Lua. So exporting what we did in Kamailio for our config file makes no sense to do, like search, And I decided to go now with like 1024 pre-generated wrappers, so pre-generated C functions, which practically inside them they execute a common function with an index. So practically I have a table. At the beginning, this is populated up to like from this function with 0 up to 1023. And this will be empty. And as we load modules in Kamailio, we put here what's exported to Kemi interface. We populate the second part of the table. And then, practically, when the function is executed in Lua script, this gets executed, but inside it, and we'll see in the next slide, is practically saying execute this part of the array by index. So we have the index coming from the left side to point to the right side, which is the wrapper around Kamailio function. So again, we start with an empty table on the right side. We load module, and Kamailio startup will populate this second table. So that function that's on the left side in the previous table, it's practically that 4 lines up there is just a wrapper to another one giving the index. So it's Lua state plus the index. And they are generated, they are statically generated right now. It's a script inside our module app Lua that generates it. We'll have to increase it if someone complains that it's not enough. And this is the structure that it's in the right side. So practically would be this Kemi is the structure that points to our module function and the C function corresponding to it. And again, initially, this is practically the table. It's also statically defined. Left side, it's populated with pointers to the function. The second side will be populated at startup. And here it's getting the index based on what's executed by so practically this function is executed by all those statically generated, and we'll get the index, and the index returns that wrapper we have for our Kamailio modules. So I did the testing with the second approach, and practically there is no difference. This is microseconds, and that's native and Lua for a rather complex configuration file. So practically the average is more or less the same. I couldn't notice. Sometimes it was even better. The maximum was actually better for Lua. This is one of the examples because again it was really no difference. We kind of execute more or less by pointer. We have a single step of finding the function pointer by an index. So the benefits here, and I'm getting very fast to the end. Of course, Lua has a better documentation, and it's a larger set of extension. You have, Lua extension for a lot of other things. Also, testing now should be easier because Lua has some testing frameworks that you could put inside your config file. And one of the most demanded from Kamailio side, you can do reload of this scripting language. I give here an example of like a real benefit will be sending a Twitter message when you have a missed call. So I'm calling you, you don't answer, then the server could send you a direct message. Practically, you'll have to keep a mapping. So here it's a table. You have to define, create it, and keep the mapping between Twitter user ID and SIP user ID. This would be the Lua script for sending a tweet. So it's already a Twitter package, and then you have to use these authentication tokens, and then sending a message would be like just this. Implementing this as a Kamailio module will be probably a lot of C code. And I put here more resources that if you want to read, one of quite important, probably for Kamailio guys in the room, would be listing the APIs function available that we export. Will be this an RPC Command Api List, and also reload. You have direct links to it. This is the link where we document the SR package that Kamailio exports to Lua interpreter. KSR needs to get its own documentation page, I expect. But again, for KSR, you can list available functions with an RPC. So you load your modules, you do this command, and you see what's available there, the name of the function and the type of the parameters. Right now, of course, it's kind of like one-to-one relation to what's inside the configuration file. So like T-relay for sending out in transaction mode will have an equivalent. KSR, name of the module, typically tm.T-relay. So as I wanted to have like 5 minutes discussion, I'm ready with this. And again, I'm also open for suggestion. If someone more familiar with Lua could give us better solution for, I don't know, this exit, or for, you know, dynamically at the startup of the interpreter plugging.
Daniel, let's do one question because we need to set up for the panel.
Yeah. Okay. So, questions? Yep.
So you said that users can go to native exit from Lua, so you give them access to all the standard libraries. So you we trust our users. Okay, there is listen looking at it.
Yeah, so we give full access. We don't try to limit it, just try to document it. Because also in Kamailio we have a function that's called abort, because sometimes it's used to make a crash and you want to get the core dump. So practically Kamailio doesn't do anything if you don't have a scripting language. So we give full power to our users. And if it's crashing, it's their problem, not ours. We are open source. Okay, then I'll be in the panel afterwards. Thank you for coming now. I see a big group of people. And again, thank you to all the FOSDEM organizers. And admin of the rooms, because without them would be no FOSDEM.